Yeah, Greg, thanks so much for being here.
Thanks for having me. It's a beautiful studio.
Yeah, so you just flew into San Francisco for a couple days from LA.
Yeah, based in LA. I always joke that it's a shorter flight up here than it is for me to get to the east side of LA. So happy to come to SF anytime.
Yeah, what is the LA scene like in terms of startups and AI?
I feel like it's really been picking up. So, there was a point where Snapchat was really hot that they were calling it Silicon Beach. I feel like they've kind of dropped that narrative ever since Snapchat moved out of their office, but that office has kind of become a co-working space. And I moved there at the end of COVID, so 2022. Felt a little dead when I first moved there, but it's just been like picking up. And we run a lot of the events for the community, so it kind of feels like we're the AI company in LA, so a big fish in a big pond. And then I come up here and I'm like, oh, it's a completely different scene, So love to travel up here and just see all the expertise.
Yeah. Does it feel like LA is also like completely full of AI startups right now? Like San Francisco very much has this feeling everywhere you go, every coffee shop, there's people working on AI. Is it similar?
I'd say LA's got like a much more diverse set of startups that I meet. So there's a lot in like the media and entertainment space, a lot of consumer, a lot of brands. So it's been fun being like the AI company that kind of consults with those companies, and we can bring our expertise to the, less AI native companies.
Yeah, that makes sense. Okay, so you're the founder of Oxen. I want to talk about what Oxen is, but can you tell me more about your backgrounds? I know that you've been training models for years.
Yeah. So I've been working in AI since 2012. So the very early days of deep learning. Right out of school, I joined a wee startup that was doing deep learning before any of the like TensorFlows or PyTorches of the world. So we were writing our own neural net libraries from scratch in C++, training convnets. And then there was the AlexNet moment that really like blew our minds when, this convolutional neural network beat all of the handcrafted features on ImageNet. So we just went all in on deep neural networks. That was called Alchemy API. And that company eventually got acquired into IBM, into the Watson group. And our job was going into IBM Watson that won Jeopardy back in the day and like replacing all of the models that were like logistic regression models or maximum entropy models with deep neural nets that could do the same but generalize better to the data. And so we would come in, IBM would go sell like a big contract to be able to do some natural language processing task. And then they'd bring the requirements back to the engineering team. And we were part of a fast domain adaptation team that would have to like get our models to work in Korean on a financial data set. And we don't even speak Korean, but like as long as we get the data, we're able to customize the model and then hit whatever accuracy the customer asked for. So that was kind of in the early days of my career, and did a bunch of reps of just going from a research idea to a production deployment. And almost every single time it just came back to what data we were feeding into the model. And so that kind of sparked the idea of Oxen. Was we actually started as a data management layer, version control layer for machine learning data sets, because it's really just like, garbage in, garbage out, or good data in, good data out. And started to see some traction there. But what's really kind of been picking up is fine-tuning some of these foundational models or open source models on the data sets. So pairing the data with the compute and infrastructure and letting a company own their own model end to end is really where we're seeing traction now.
Okay. So Oxen started as managing the data.
Yes. Yeah. So we started with a version control tool to replace Git. So we actually rewrote like the internals of Git to be able to scale to like terabyte size data sets. So this was kind of in the pre-Chat GPT era where these pre-trained models would take a ton of data, and we were just saving them in like S3 buckets with no sense of version control, no sense of what data trained what model. So that's where we started, was like, could we build a distributed version control that actually works. If you've ever hit the limits on GitHub, it's like 2 gigabytes of data that you can put in there. So ours scales to like, I think our biggest deployment has 20 terabytes of data in it and thousands of engineers like collaborating on the same repository.
Okay, so you were doing this for a while, but then eventually it changed into what Oxen is today.
Yeah, so it turned out that a lot of people were using the version control tool to fine tune their own models as like a natural use case for it, because you have to pair what data set went with what model, and you might have like a bunch of models deployed out in the edge or models deployed in your own infrastructure, and being able to tie that specific version of the data set to the model weights. And both the data set and the model weights can get pretty hefty. Like the DeepSeek models are 600 gigabytes alone, the model weights. So how do you store and manage the connections between those?
Okay, so your customers were basically using this in this way, and you started realizing that's what they wanted. Okay.
Yeah, and they were having to home roll a lot of their infrastructure to like build on top of our version control stack. So they would take it, wire it up to their compute infrastructure, and have their own training loops. And the time to like value for some of those customers was the time that it took their engineering team to integrate the version control tool with their training infrastructure. So we were like, what if we just paired it with a training infrastructure that kind of came out of the box, one click, go from your data set to a fine-tuned model, and then eventually deploy it into your production setting.
Okay, so that's basically what Oxen is today. Like if you were to describe it for someone who wasn't listening.
Yeah. So today I would say it's infrastructure for fine-tuning models on your own data sets.
Okay. And can you talk about some like customer use cases or someone who might use you, what their use case would be?
Yeah, so we work across a couple different modalities. So there's the classic LLM use cases for like text in, text out, classification, agents making tool calls, or name your LLM use case. And what we're seeing is a lot of people who would build the MVP of their application on OpenAI or Anthropic just to like see if this is possible. And then they start to run into either accuracy because it's out of distribution, or speed or latency requirements that they need, or even just privacy. And I just don't want this data like leaving my infrastructure and going to some other cloud. And so they either take the data that they've collected in production or do some hand labeling, fine tune their own models. And now they have like full control over the experience from a latency, cost, or accuracy perspective. So that's kind of on the LLM side. And then on the diffusion model or image generation, video generation side, we're seeing a lot of people who care a lot about the quality of the output. So there's the meme of like AI slop going around with Sora and all of these image gen models. And we're based in LA, so we have some clients that are Hollywood grade. They need it pixel perfect on every single frame, and they're going to have their VFX coordinator looking at it and marking it as an AI shot, but it has to look as if it's not. So in that case, quality matters a lot, and fine tuning can kind of take you from an 8 out of 10 to a 10 out of 10 in quality.
Right. So they want pretty much every single pixel to be quite perfect, obviously, Hollywood.
Yeah. And, these video gen models are getting pretty good. Like you see the Google VO models or Sora, those are more the consumer grade ones that people are playing with. But then there's the open model ecosystem, ones coming out of Alibaba called Wan, and the Chinese labs are actually leading a lot in the open ecosystem. But I had a demo last night at AI Tinkers trying to describe how well these models are working. And the real Hollywood use case is they messed up one of the shots, and they accidentally had the actor wearing like a white blazer in the scene when it should have been his red one. And so they were like, everything else about the scene was amazing, but can we just swap him into the right outfit for this 10-second clip? And so it has to be pixel perfect, or they would have to call everybody back in, do the reshoot again. And they're like, if we can do this with AI, we'd rather do this with AI. So just as a quick demo, last night I took that. Obviously, I couldn't use the real data, but I took Pulp Fiction and that like famous scene where Samuel L. Jackson and John Travolta like raise their guns slowly. And I was like, can we swap the jacket that Samuel L. Jackson is into like a cool red leather jacket instead of his suit? And how quickly you can do that and how high quality you can get these models is just like blowing my mind every day.
I didn't realize that that was the Hollywood use case where there's like maybe a small bug in one of the scenes and then you swap it out or change it.
Yeah.
That was quite interesting.
Yeah, or you can even think of like the clock on the wall in the back isn't matching from the other scenes, or like the time, they'll just like switch it real quick with AI.
Do you just expect this to grow in the coming years in terms of like Oxen's role in this?
Yeah, I mean, I think it's interesting to see the shift in Hollywood. I'd say like 2 years ago, you saw the actors strike and you saw a lot of people in Hollywood being against using AI. And more recently, I go to these Comfy UI meetups. I don't know if you're familiar with that tool at all.
No.
It's kind of this node-based editor where each one of the nodes can be like a diffusion model or like some sort of AI process. And they'll be chaining together AI tools. So it'll be like video in, and then the first module extracts masks. So like the mask might be the jacket itself. So in each frame, it's kind of got like a segmented out jacket. And then you're passing each one of those frames into another model that's filling in the jacket with the real thing, but you're not touching any of the other pixels in the frame. It's just like just filling in where that mask is. And with that level of control, plus a little fine tuning, you can get these things to be like pixel perfect. I wouldn't even be able to tell the AI was involved.
That makes me wonder about how far away we are from entire movies just being generated with AI characters.
Yeah, it'll be interesting. These things do really well for like 5-second clips right now. So for these like bugs, like you said, or just like shots that they need to swap, I feel like it's really good for that now. But for a longer form film or movie, they're having a hard time with character consistency or like scene consistency between those 5-second clips being like chained together in a fully automated AI way. So I feel like we're still a ways out from that. And I still think people are going to connect with like the humans in the movie. Like you're going to go see the Nicole Kidman movie because you really like Nicole Kidman, right?
Yeah, and not your favorite AI bot actress.
Yeah. So I think there will still be humans in the loop, but I think I frame it as a VFX problem more than like an AI problem. And you're just like speeding up your VFX team, right? Who might be adding the cool CG that they might take them a couple weeks to work on before, but now they can do in a day or two.
The Hollywood use cases seem like quite interesting use cases for diffusion models. Do you see this in other industries?
Yeah. Actually, the advertising and branding, and like you can think of Super Bowl commercials or like even music videos, we're seeing traction in. And these brands have big budgets, like name your favorite soft drink, and they have to make like a 30-second Super Bowl ad, and they will be like fine tuning actually on their previous catalog of things that they've photoshopped in the past or things that their VFX artists have done in After Effects. And so they have this big catalog of things that they've created before. And that's a great data set to fine tune a model on. But now it frees up their artists to get creative with the scenes and try something that they like, might take a month to do in post, but they can just like prompt their way into a really cool animation or something like that. So we've seen traction with the agencies who are then going and pitching out to multiple brands. And this agency has the problem of like, okay, I fine-tuned a model for brand X and a model for brand Y and a model for brand Z, and being able to have all of those data sets kind of sectioned off from each other, and exactly what version of the data set trained what model. That's one thing that they're loving the Oxen platform for, because the version control plus the data storage plus the fine tuning is like the perfect storm for them to scale up their operations.
That makes sense. I also wanted to ask why the name Oxen.
Ooh, it's a good question. I'll give you the branding answer and then the real answer.
Perfect.
So what we like to say is Oxen takes away the grunt work for you. And if you think of like the agricultural revolution back in the day, it was the ox and the plow plowing the fields that allowed the humans to focus on other things like arts and sciences. So we say we plow and maintain your infrastructure, your data sets, your GPUs, your fine tuning so that you can focus on your product or your end goal. But the real answer was I was camping and it was the middle of the night and I was trying to think of a name and I woke up at like 4 a.m. And I was like, is Oxen AI taken? And I was in the middle of nowhere and didn't have service and I had to like write it down, in the notes app on my phone. And then the next day I like rushed to a coffee shop or something and saw that it was available. And I was like, 4-letter domain name with an animal, with an emoji. There's an ox emoji. And I was like, I'm sold. I'm buying this.
That is good. Yeah. So Oxen.ai.
Oxen.ai.
Oxen.ai. That's perfect. Yeah. You had to go check the domain first thing. Yeah.
Yeah. And I was like, I will fill in the backstory for what oxen means, but I'm snagging this.
That's perfect.
Yeah.
You guys are using a lot of Rust. Is that right?
Yes.
What has your experience been? I love talking about programming languages. Like, what has your experience been? I'm assuming most of your team members probably didn't know Rust to start out with.
Yeah, so we have a pretty interesting stack. We actually use Rust and Elixir, which are two pretty niche programming languages. Have you done any Elixir before?
No, just Rust, just a little bit of Rust, but nothing in production or anything.
Yeah. I would recommend Elixir too. They're probably my two favorite programming languages. Both have kind of different properties. Elixir is built on top of Erlang, which is infamous, not notorious, for being the infrastructure for WhatsApp when they started. And they scaled like a single server for WhatsApp for like an insane amount of time. The number of requests and messages that were being sent through, I forget the number, but if you look it up, it'll be like maybe in the billions. And they just like never had to switch from this little box. So that's what Elixir and Erlang is infamous for. So we use that for a lot of the like API requests and routing and all that kind of stuff. And then for Rust, we actually built our own file system and version control and had to have it scale to these massive data sets. So like every little bit of performance that we can get out of the programming language is important to us. And I come from a C and C++ background. So you kind of get like those performance guarantees, but with the memory safety and memory management, where you're not having to think about pointers and cleaning up the memory as much.
Yeah, I do love C and C++, but I feel like that's quite an unpopular opinion to say.
I know. It was one of my first loves, I would say.
It was my first love, and then I went on to JavaScript and things, and they just weren't as appealing.
Yeah. That was what we were writing the initial neural networks in, and even built like a question answering system that was just as fast as IBM Watson. And if you remember, IBM Watson was like it was like the size of an entire server room holding all of Wikipedia together. And at this little startup, it was called Alchemy API. We like built our own version of IBM Watson internally with all of our little neural networks and stuff like this. And we wrote it in C and C++, and IBM had written everything in Java. So that was always our jab at IBM before we got acquired by them, is we're like, our memory usage and CPU usage is just so much slower. You don't need this entire server room to run IBM Watson. We can get you down to like a single server on an SSD. So yeah, C and C++ all the way.
That's awesome. Yeah. Tell me more about your recent launches.
Yeah. So we've had a couple fun launches, and we're actually doing one with Baseten this week on our training infrastructure. But we've been testing it out with pilot users for the past couple months. And one of my favorite customer stories is, there was a big craze when the Google model Nano Banana came out, this image editing model that could take in a reference image and a prompt and then generate a new image. It can actually take in multiple reference images. So you could be like, a dress and a woman, and you could be like, put the dress on the woman, and it'll just do it. And this Nano Banana model just kind of took the internet by storm. Everybody was so impressed at how well it worked. And so we had a customer come in, and they had a really cool use case that was they're working with a big Swedish furniture manufacturer who has a bunch of different SKUs of their product. And they wanted to roll out a new set of color swatches to go on top of them. So you can think like desks and drawers and cabinets and stuff like this. And so they have their existing product catalog, and they wanted to apply like blue drawers and a red frame or something like that. And there were 192 different color swatches and like 32 different styles of furniture. And to be able to do a photo shoot of all of those combinations, it's 1.2 million combinations of colors and places that you could put the furniture. And so they were like, I wonder if we could use a model like Nano Banana to just have the user be like, I want blue drawers and a red frame, and then see how that color combination looks together. And so they did a few iterations with Nano Banana, and they're like, it works like 50% of the time pretty well, honestly. Like they could probably use this in production, but then the other 50% of the time, the color of the blue would be like not the exact sky blue that they wanted, or the color of the red would be a little too dark. And so what they ended up doing was they used a combination of Nano Banana and ChatGPT image and Photoshop and contractors to like put together a little training data set of all of the color combinations, the exact colors that they needed in the final rendering. And this new model came out called Qwen Image Edit, which is like an Apache 2 open source version of Nano Banana. And out of the gate, Qwen Image Edit could do the task maybe a little worse than Nano Banana, but we were like, I wonder with fine tuning how well this model will perform. And they did their first pass just on 100 images, just to like proof of concept. Can it nail the colors? Can it nail the scene? And the first fine tune that we did got better results than Nano Banana. So their eyes just like lit up, and they're like, okay, let's scale up our data labeling. Let's do like a proper training run on this. So I think they ended up with a couple thousand examples that were either auto-labeled by Nano Banana or ChatGPT, or got sent off to a contractor to like Photoshop in the proper colors. And they fine-tuned this model, and it ended up being more accurate than Nano Banana. And the cool thing is that it's now Apache 2. They can like deploy this into their own infrastructure, and they can even deploy it onto services like Baseten. And per image, if you were going to do this on Nano Banana, it would cost $50,000 because it's like 4 cents per image at 1.2 million images. So that's around $50,000. With the Qwen model, they got that cost down to $7,000 to generate all of those images. So not only was it more accurate, but it cost them it saved them almost 40 grand in production. So
That's quite an interesting use case. I think I wouldn't have thought of that use case, but when you say it, it seems quite obvious.
Yeah, and it's like I've learned so much from this client alone on like the precision they need on the colors. Like you wouldn't think of how hard of a problem that is until you see, the color blue has to be that right color, and it has to have the shadows and like depth that it would in the real world while maintaining that color blue. So you can't just like pixel for pixel swap out the color blue. It has to look realistic in the render as well.
That makes sense. So you talked about Baseten. I want to talk a little bit more about Baseten and Oxen. So you're using us for our training platform. Can you talk more about that?
Yeah. So originally met you guys, I think, as presenting as one of our Friday events we do with the community, and we were talking about training small models, and Bola was actually in the audience, and he came up to me after and he's like, are you guys working with a lot of customers with small models? And then he's like, are you doing any fine tuning? And I was like, Our customers are, but we haven't quite like integrated that into our product yet, but we're thinking about it. And he was like, well, let me let you in on a little secret. We're launching some training infrastructure. Maybe we can partner on like seeing what it would look like to bring the data sets and the compute together and see if we can kind of have like an all-in-one solution for the customers to go straight from data set to model weights to deploy. So it was like a month or two us talking about it, and then we decided to tackle it. And within, I think it was like a month and a half, we had the end-to-end prototype, and we started to have customers kick it around. And the reaction was, oh my God, I used to have to spin up all of these like run pod instances myself, or like manage my Lambda Lab or Vast AI cluster. And like I'd kick off a training job and know that if I didn't wake up at 4 a.m. to kill it, I'd just be like spending extra cash on this GPU without it spinning down. And once we integrated like the end-to-end data sets plus fine-tuning infrastructure from Baseten, it's literally one click to kick off an experiment. And we see customers kicking off like 10 experiments at once. They're training on a bunch of different GPU clusters, and then they all wind down and save the model weights back at the end. So kind of has given our our users superpowers of being able to explore the hyperparameter space and then look at all the outputs of all the different models and be like, ooh, okay, learning rate of 0.3 works well, and batch size 4, and time step type sigmoid, like try all of these combinations in parallel without having to have, a PhD in machine learning or worrying about out of memory because they didn't pick the right GPU or any of that. So it's really been like a magical experience for the customers, and it's been fun to see how quickly they can go from, I have an idea, I wonder if this would work, to, oh my God, it works. And we just like get these messages from our users on Discord like, I can't believe that worked the first time we tried it, because normally a machine learning engineer would spend a week or two just like fiddling with things.
Right. And you used Baseten, I thought was quite interesting, via an API.
Yeah. So we kind of use you guys behind the scenes under the hood. And so we've kind of set up for each one of these open source models, they have different GPU requirements. So, if you're going to fine tune GPT OSS, you might need a cluster of 4 by H100. So, an H100 has like 80 gigabytes of VRAM. And to do a full fine tune on that, you need like 240 gigabytes. So we've done the mapping between what model are you training, how big of a data set do you have, how big is your batch size, how big is your sequence length, so that when you kick it off, you can have the confidence that like, I'm not going to spend a lot of money on just an out of memory error. So we've kind of done that math, and then it's been great partnering with Baseten because we don't have to worry about where do we get those GPUs? Is AWS out of capacity? Do we get them from GCP? Do we like roll our own on Lambda Labs? It's just like we can focus on the software, and you guys can focus on getting us the GPUs we need. So having that be API driven has been a really nice experience for us.
That's really cool. And then for the trained models, like how are you deploying them in production?
Yeah, so we also use Baseten for that right now. And there's kind of two use cases that our customers come with us for. Either they want access to the raw model weights and they just want to like download it into their own infrastructure, or even onto their laptop and run it locally at this point, because some of the models can run locally pretty quickly. Or they want to deploy it to a managed service. So we do the same kind of thing that we do on the fine tuning side of, okay, I know it took 4 by H100 to fine tune this model, but it only takes 1 H100 to run it in production. And so we set up all the Docker images, set up all the dependencies, and let you just like one button deploy. That goes to a cluster of GPUs in Baseten, and then they can just hit it with either our API key, or eventually we want them to be able to bring their own.
Okay, that's really cool. Something I see a lot is people constantly trying to figure out, especially with all the new models coming out, like which model to use and which model is best for each task. I'd love to hear your tips on this.
Yeah, it can be a bit overwhelming. I feel like every week there's like a new launch of a new model that claims that they're better at XYZ. And so the first thing I always tell customers is like, make sure that you understand your requirements first and foremost, and what problems you're running into in production before you just like go and hot swap a model. Because who knows, like just because ChatGPT got better at coding doesn't mean it's going to be better at your like document processing use case. So that's the first thing that I say is like, make sure you have some sort of baseline or benchmark that you have in place so that you can confidently switch between models. But on a more practical side of things, or just more opinionated, I do think the Qwen series of models have been really impressive, and that lab has just been shipping like crazy. So there's something that they've done in the Qwen language models that make them pick up information super quickly. And we've seen the like 8 billion and 4 billion parameter models there be really good if you have a very well-defined task. Like if you don't need it to also generate poetry because you have like more of a business use case, those models can pick up that task really quickly, and you can deploy it at scale. And even some coding use cases, like, you know, you can picture like a cursor tab. I'm not saying they use Qwen in the background, but I would guess they use Qwen in the background for that. And then from a video generation side, I think the WAN series of models are really cool from an open source perspective. I'd say they can get you even higher quality than a Sora generation if you're willing to give the compute to it. And that's also from Alibaba. So I'd say Alibaba's kind of like crushing the open source game. And I'd hope to see, I'm excited to see what Meta will do next with their series of models. I feel like the Llama models were very strong when they came out, and I have a sense that they're going to drop something soon with their new super intelligence team that's going to be like the American version of that. A good new model. Yeah. So excited for that too.
Yeah. Okay. I want to talk a little bit about Fine-Tuned Fridays. Wait, Fine-Tuning Fridays.
Fine-Tuning Fridays. Yeah.
What is this? Tell us a little bit more about this.
Yeah. So we do an event on Fridays called Fine-Tuning Fridays, and it's live with our community, and we'll pick one of these open source models. So this is kind of where I've built up some of my intuition of what models work, what models don't work. And we try it on a very specific use case, either one that we've heard from a customer and use like a different data set than them because they won't give us permission to, or we've done some where we just partner with the customer themselves because they want to talk about their really cool example that they've done. So for example, this Friday, we're going to be doing the furniture one that we just talked about. So if you're curious, like, what did the data set actually look like? What hyperparameters did they choose? What roadblocks did they run into? And then how did they deploy that actually in production? We'll talk through all of those details. And it's supposed to be like a really practical, no hype, like let's look at the data, let's look at the model choices, let's run a couple experiments, and then we'll look at the outputs together. And just like, I feel like a lot of the research papers, they'll show you a bunch of bar graphs and you'll just be like, cool, that looks like it did better than the other model. But until you look at the actual inputs and you look at the actual outputs, that's where I feel like the rubber meets the road, and you can really like get a feel for how well these models work.
Yeah, that's really cool. It's great that you live stream as well. It makes the company feels really accessible when there's live streams.
Yeah, and it's been fun having, I mean, we have the same people that have been showing up for over a year. It's like familiar faces hop on the Zoom call, and they're like comfortable asking questions to me and have like good rapport. So we definitely have a bunch of people that watch on YouTube, but if you can make it on a Friday, I'd recommend it because it's like a fun back and forth that we have with folks.
Friday seems like a good day to do it. It seems like a little bit less rushed than other days of the week.
Yeah. And it's alliteration, so we got to do that.
Absolutely.
We actually, so it's funny because we pivoted. We initially started with a series called Archive Dives, which also has a bit of a ring to it. But one of my favorite ways just to stay up on the most recent changes in the AI field is finding the research papers that have been trending on Twitter or like are backing that state of the art model that are out there today. And I feel like there was a period where I felt like I was very behind, quote unquote, on AI. And I was like, okay, I've been doing some computer vision work, but what are these transformer models? How are they being applied? And so for myself and even for the Oxen team internally, what we did was we started a little paper club internally to the company where every Friday I would pick a research paper and then the team would go read it and we'd all come back together and chat about it. And we were doing that every Friday consistently just to like upskill the team internally. And one of our engineers went on sabbatical for 6 months, but his one request was like, can I still come for our paper club on Fridays? So that made us think, we were like, sure, you could come, but maybe we'll just make it like a public Zoom call where like anybody could come. And I think the first week we had like 2 or 3 people that dialed in and was like, that's cool. Like, we never met you before. I forget, maybe we were posting it on Reddit or Discord or something like that. And then eventually it was like 10 people and then 20 people and then 40 people. And then we were getting like up to 100 people dialing in for these archive dives where literally we would just like go over a research paper and tell you what the key takeaways were. And more people were like, this is great to understand the underlying research and what models are out there and what even a transformer means. But like at this point, I just want to know what models will work in production. So we kind of changed it to fine-tuning Fridays where we're like, okay, we'll still give you a intuition behind the architecture and the models, but we want to show you how this works in the real world and run it on some real world data. So it's been fine-tuning Fridays ever since.
That's really cool. And where do you stream at? Twitch, Twitter?
We do it on Zoom. Actually, we probably should switch to YouTube.
Zoom stream.
Yeah. And then we record it and we put it on YouTube afterwards. So if you check out at Oxen AI, we have, I think, over 100 videos on there now of different models.
Cool. I think this is a good place to wrap up. Thanks so much for talking.
Yeah, thanks for having me.